In the last lesson we looked at the expected value of a continuous random variable, and we looked at the median of a continuous random variable. So today what we'll do is go to the next thing, which is once we know the center of the data, how do we measure the spread? And there's two ways that we look at with spread. We look at the standard deviation, and later on we'll look at the interquartile range. So to get the standard deviation, we go through the variance. So the variance itself doesn't have a lot of meaning, but it's used to obtain the standard deviation. So remember, variance is called sigma squared and standard deviation is sigma, i.e. the square root of the variance. So it works the same way it did with a discrete random variable. So what basically happens is you remove the mean from the values that the random variable can take, and then you square the values and you sum those squared differences together. So that's basically what this formula does. And the standard deviation, as I just said, SDX is equal to the square root of variance. Now, as is the case with discrete random variables, we use this computational formula for variance. So the formula sheet will have, I think it might have something like this on it. In fact, I'll pause this video and bring it up. Alright, yeah, so here is the methods formula sheet, and here's continuous probability. So this is how we found the mean, this is what we used last lesson, and this is how we will find the variance. So this is the one on the formula sheet, but again, what we're going to use is this version of it, the computational version of it. There's a proof to explain how that is derived from that. I can't do that proof, I just use the formula. Okay, so that's just a summary of how we find the mean and variance of discrete and continuous random variables. I say we go ahead and do it. Okay, so find the variance and standard deviation of the random variable x, which has the probability density function with the rule this. Right, so basically it is 0.5x between 0 and 2, so it's this, and then it's 0 elsewhere, where we're including that and that. Okay, so the variance is found by, well, what we need to do is the variance of the random variable is found by doing e of x squared take away mu squared. So essentially we need to find the expected value first of all, okay, and then we need to find the expected value where the random variable is squared. Okay, so I think I'll find e of x equals mu first of all, which is integral x multiplied by 0.5x, again this is just from last lesson, to 0 dx. So that is going to be integral half x squared dx between 2 and 0. And if we anti-derive that, we've got 3/1/6 out the front, x cubed to 0. Let's just check that. So raise it, divide by it, which is multiply the reciprocal, 1/3, 1/6, 1/6 comes out the front, and then we're going to pop our terminals in, so it's 2 goes in, 1/6 times 8, take away 0 square brackets, which is 8 on 6, which is 4 on 3. So that's our expected value. Alright, now what we need to find is e x squared. So that's pretty simple. Instead of using this, x by this, all we do is we just use x squared there. Alright, so it's going to be 2, 0, x squared times 0.5x dx. Let's just check that. Yep. Okay, so this is going to be 2, 0, half x cubed dx. So that goes to the 4. Divided by 4 is an eighth. So it's 1/8 x to the 4, 2, 0. 2 to the 4 is 16. I know that this will be 0, so it's 16 over 8, which is 2. Okay, so let's go now and work out the variance. Equals e of x squared, take away mu squared. So e of x squared is 2, take away mu squared. Now mu we worked out was 4 on 3. Okay, so that's going to be 16 over 9. This is 18 over 9. Which leaves us with 2/9. So the variance is 2/9. Alright, so find the variance and the standard deviation. Okay, so that means that SDX, or sigma, equals the square root of 2 over 3. So that gets square rooted, and that gets square rooted. Alright, so there's everything there down. So it's fairly clunky and cumbersome, but yeah, that standard deviation is a good way to determine or to talk about the spread. So speaking of spread, as already stated for discrete random variables, it is also the case for many continuous random variables, not all of them, but many continuous random variables, that about 95% of the distribution lies within 2 standard deviations either side of the mean. Okay, so all you do is you find mu and you find sigma. So this is the mean and this is the standard deviation, and you go 2 to the left, so 2 standard deviations to the left and 2 standard deviations to the right, and then what we can say is we are 95% confident that the random variable can take on values between, and the lower value is this one here, and the upper value is this one here. That's for many continuous random variables. For some, it won't be a good way of talking about how spread out the data is, but it does for a lot. Okay, so the range of a random variable is the difference between the smallest and the largest value the variable may take, and is determined from the domain of the PDF. So determine the range of the probability of the random variable x, which has the probability density function here. So again, it doesn't really matter what the function is. This is a really easy problem. So the range is equal to the max value, take away the min value, and that's 3 take away 0, which is 3. So the range of this one is 3. A lot of working out space for not a lot of work. Okay, the IQR. So the interquartile range is the middle 50% of the distribution, and it's the difference between the 75th, known as the Q3, and the 25th, known as Q1. So let's get the interquartile range for the random variable x. Right, now how's this going to work? Well, let's just quickly sketch this. So it's 2x between 0 and 1. And it's 0 elsewhere. Alright, so basically what I want to know is at what point along here am I getting this area here, which represents, so this part here represents 25%. And same up this end here. So what area here, or what value along here will be the upper 25%, okay? So that's what I want there, that area. Okay, so in fact that's not quite right. Okay, so I'm going to have to edit this so that I cut this back in. Okay, and on to the interquartile range. So the interquartile range is the range of the middle 50% of the distribution. The last time you saw IQR was in year 10, I think. So it's the difference between the 75th percentile, known as the Q3, and 25th, known as the Q1. So the last time you saw these were as box plots. And the IQR was this part here, which is the Q3, take away this part here, which is the Q1. We used to use it, or we used to, but we still do, use it when the data has outliers. That the Q3 and the Q1 were better represented, a better representation of the spread of the data. Okay, so let's just see how it works with a continuous random variable. So sketch the graph, 1, 2, 0 elsewhere. Okay, so basically the way it'll work is we want to know the 25th percentile. So we want to know when the area here is going to be 0.25. And then the second one we're trying to find out is when the area goes up to, so what value here? So this value and this value here, so that it is, I'll draw it in a different color. This area here is 75%. Alright, so the way we're going to do that is similar to the median, and really it's the same calculation as the median, except this time we want percentile 0.25, or the 25th percentile and the 75th percentile. So we're going to say 0.25, this is the Q1. So 0.25 equals integral 1, 0, 2x dx. 1, 0, what am I doing? So that is going to be, let's call this A0. I don't know what the value is. Alright, so 0.25 equals, so that antiderivative is x squared, divided by 2 is x squared, A and 0. So A goes in, A squared, and 0 goes in, leaving us with 0, so it's just going to be A squared. So A equals plus or minus, so the square root of 0.25 is 0.5. So plus or minus 0.25. Now, why is there two solutions? Well, remember, what it's giving you is this other one over here. So 0.5. We don't want this one, so we're going to say but A greater than 0. So A equals 0.5. Okay, so the Q1 is 0.5. Alright, so this value here at the halfway mark is going to be the 25th percentile. Alright, the 75th, so let's get 0.75 equals, let's go B0 to x dx. Okay, x squared B0 Okay, so much easier to flick this one to a fraction. Probably would have been easier with this one as well. So B is root 3 on 2, which is, what's root 3? 1.7, 0.8 or something like that. Okay, so that seems to make sense. Right, so the IQR is the Q3, take away the Q1, which is, in this case, A is half, take away root 3 on 2. So the IQR is 1 take away root 3 all over 2. So that is the interquartile range. Alright, so just like discrete random variables, if you've got a linear combination of variables here, then you can use this property, and same with the variance. You've got this bizarre A squared multiplied by the variance of x. Okay, so this is what we covered in, I think it was 13C for discrete random variables. So go check out that for a review, but it only holds true if we've got a linear function. So 15C, and you're now ready for the chapter review and ready for this new exciting thing coming up next, which is the normal distribution.